Very good day to all of you. My name is Rakesh, working as Assistant Professor in Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. In this session, I am going to handle about mechatronics and robotics. Let us see introduction towards mechatronics and introduction towards robotics in this session. First, before going to the mechatronic systems, earlier we had a mechanical system. So for every system, there is a certain objective. Consider this is a classroom. Classroom is a system which consists of bench, tables, desk, blackboard, everything. So this is a system, and the objective of classroom is to impart the knowledge. Similarly, for every system, we will be having a certain objective. Even a fan is a system. The objective of the system is to just give the air. So like this, there are several systems. Earlier, they were only mechanical system, they were only electrical system. Mechanical system means a system which is having a mechanical components. So it can be any machine type, it can be just a stereo, or it can be just a tape recorder. So these systems will be having only a mechanical components. Analog alarm clock. The timing of the clock is adjusted with the help of mechanical elements. Because of that, it is working purely on mechanical basis. That's why the system is called as mechanical system. Electronic system is also there. Electrical system is also there. If we consider electronic system, it is a RAM. RAM consists of several types of electronics devices like ICs and all. Even an integrated chip is also an electronic system. Electrical system, it can be anything, purely electrical, which runs only on voltage and current. So these types are nothing but a pure systems. Let us see what exactly a mechatronic system is. Mechatronic system is nothing but it is an complete integration of mechanical system with electrical, electronic and computer systems into a single system. Only mechanical system will not constitute mechatronics, only electrical system will not constitute mechatronics, only computer system will not constitute mechatronics. Mechatronics will be constituted only if mechanical system is integrated with electrical, electronics and a computer into a single system. The whole system is nothing but mechatronic systems. The examples for mechatronic system is a DVD player, hard disk, even an automatic camera and automatic washing machine. These are the several examples for mechatronic systems. How this word is arrived? This word arrived from the two different words. One is mechanism and electronics. Basically what we will do is we will interface electronic components with the mechanisms, then we get some motion. It can be any linear motion, it can be any translation motion. So this is nothing but mechatronics. This was originated by a Japanese. This is a Japanese origin, mechatronics, and mechatronics is very useful nowadays in industry. Nowadays industry running with purely mechatronic system. It is not purely electrical, it is not purely any other thing. It is completely mechatronic based. That means mechanical alone cannot be working in the industry, electrical alone cannot be sustained in the industry. So whenever you want to work with an industry, you need to have a knowledge of both mechanical as well as electrical systems. So it is a mechatronic systems. So here another important thing is this will integrate many of the disciplines. That means it is an interdisciplinary scenario. It consists of mechanical engineering, electrical engineering, control engineering and computer engineering. So this is one of the interdisciplinary scenario of mechatronic systems. And another important thing is when we miss control engineering, mechatronics is finished. Very important part of the mechatronics system is control engineering. We need to establish a relationship between hardware and softwares. Hardwares are nothing but the elements what you are going to use. Say for example, if you consider fan consists of a motor, Motor will be having input electrical energy and output rotation. So here input is electrical, output is mechanical. We are converting electrical energy into mechanical work. This is one of the example of mechatronic systems. How we will be establishing a relationship between electrical parameters and mechanical with the help of some circuit. That circuit can be anything. It can be a simple IC circuit, it can be a simple board, or it can be a complicated motherboard. So an integrated board interface circuitry can be a simple thing from a IC to any other VLSI integrations. So this is one of the important thing in mechatronics. When we consider an example of a fan, the fan consists of a motor. Motor will be having electrical energy as an input, mechanical rotation as an output. Hardware elements of motor is nothing but a fan. It is just an induction motor. We are establishing a relationship between electrical quantities and mechanical quantities with an interface circuitry. Suppose if you open a fan, you will get a circuit board. That circuit board is nothing but interface circuitry element. So that itself controlling mechanical and electrical interfacing. One of the example what we have seen is fan. Fan is electromechanical systems which has electrical energy to mechanical energy conversion. Let us see some of the examples of mechatronic systems. Let us take a simple example of fan. The fan consists of a motor. The motor input to the motor is an electrical energy. Output to the motor is a mechanical rotation. We will be establishing a relationship between input voltage to output rotation. So this is possible only if there is a interface circuitry, that is a control engineering circuit in that. There are another example like automatic washing machine. Already you know automatic washing machine. Most of you having automatic washing machines or just a washing machines. The objective of washing machine is to wash the cloth. How to wash the cloth? There is a procedure. There are 4 procedures adopted in the washing machines. Number 1 is soaking. Soaking is it is a mixing of water and detergent with the cloth. Then washing. During washing, hot water will be poured into the washing machine based on the preset temperature. Now next is rinsing. Rinsing is nothing but it is just washing of the cloth until we remove the detergent particles. So chemically what we can say is pH of cloth will be equal to pH of water. Until that condition the washing machine will be getting washed, rinsing. Finally it is a drying. In the drying we need to remove the moisture content. So what we will do is we will be rotating the drum at higher RPM so that water will be removed. So these are the 4 procedures in the automatic washing machines. Why the name automatic is because of sequence of programs we get the name automatic washing machine. So these are the 4 important things in case of washing machine. This is also one of the example for mechatronic system. Welcome for the session. Let us see an important topic in mechatronic system, that is control engineering or control system. Control system will have 2 words. One is control and another one is system. So control is nothing but it is to regulate, to command or to manipulate. System is nothing but it is the arrangement of physical elements in a rationalized manner to achieve certain objective. So if we combine these 2 definitions, when we will get the control system definition. Control system is nothing but it is an arrangement of physical elements so as to regulate or to command or to direct itself to other system in order to obtain desired output or controlled output. This is a definition of control systems. If you take an example, the classroom is a control system which consists of several elements like benches, chairs, desk, board, etc. teacher giving the classes or teacher instructing in the classes is like teacher is commanding instructions. So it is a control system. So the total objective of the classroom is to impart teaching. This is one of the example of control systems. Let us see another basic example of a control system is a lamp. The lamp consists of a physical element. It consists of a glass and helium gas inside it. So these three are the different types of elements arranged in a rationalized manner in order to obtain certain objective. The objective of the lamp is to overcome the darkness. That is the objective of the lamp. So this constitutes physical system. And if I connect this lamp to electrical circuit, say positive and negative, I will connect positive here and negative here, then the light will glow. Here the light will glow irrespective of my need. I don't have any control over this. So in order to have a control over this, we will be introducing a switch. This switch is commanding instruction to the lamp. Whenever there is a darkness, we can switch on. Whenever there is a light, we can switch off. So this is how the switch is controlling the physical system. This is nothing but a control system. Control systems are classified into two groups depending upon whether the feedback is present or not. Number one, it is an open loop control system. The name itself indicates it is an open loop. There is no feedback element. And second one is closed loop control system. Closed loop control system will have a feedback element. The system is closed with the feedback control. Hence, it is called as closed loop control system. It is also called as feedback control systems. Control system is nothing but it is the arrangement of physical elements in a rationalized manner to achieve certain objectives. We have two types of control systems basically, open loop control system and closed loop control system. Open loop control system is a system without feedback and a closed loop control system is a system with feedback. It is also called as feedback control system. Let us see one by one in detail. Open loop control system. The name itself indicates open loop means here the loop is not closed. The closed loop means here the loop is closed. Let us see what is open loop control system. Open loop control system is a type of control system where the output does not influence whatsoever on the input. So there is no dependency of output and input. In other words, what we can say is open loop control system will not automatically correct itself. That means here there is no control action for the error correction. That's why the name it is open loop control system. Initially it is having an input, it can be a reference input and a controlled output. Here we are not going to measure the output. Since we are not measuring the output, there is no error detector and there is no provision to calculate the error. That's why the name open looped. That's why control action is independent of the input. This consists of a controller, then a process unit or a plant. Process unit or a plant is actual process of the material. Let us see an example of open loop control system. There are plenty of examples in the system. So among that we have taken toasting process of bread. Toasting process of bread is, this is a flow chart, block diagram. Wherever possible you have to write the block diagram in this module. Toasting process of bread consists of a controller. Controller is nothing but a relay. Relay is nothing but it is just like a switch. Basically it is an electromagnetic switch. Then a heater. Heater will initiate heating process. First we will set a time, say for example 2 minutes. After the 2 minutes you will get a desired toast or an actual toast. By looking into the toast, by looking into the bread after the toast, you can decide whether to continue the heating process or not. Unless until we don't know what is a toast. So that's why if it is not toasted, then we will be increasing the time. Again, we will be increasing the heating process of the bread. And again, we need to see the toast, how it is done. After seeing the toast, we can decide again timing. It will not automatically correct itself. So this is nothing but open loop control system. Here there is no control action regarding the toast of the bread. Next, let us see the closed loop control system. Closed loop control system is a control system which has definite influence on output over the input. Here there is a control action. First, what happens is there is a reference value. We will get some output controlled value. After getting the output, we are going to measure that output with the help of a measuring element which is nothing but feedback. The name itself indicates we are feeding back the output. And then there is a error detector. This error detector will compare measured value with reference value and determines error signal. And this error is adjusted in each cycle. In each cycle you will be measuring the output. Error is generated, error is fixed. Measuring the output, error is generated, error is fixed. This is nothing but control action. The manner in which error signal actuates is nothing but a control action. There is a definite control action in the closed loop control system with the help of feedback device. Let us see an example of manual control of automobile in case of closed loop control system. In manual speed control of an automobile, we will fix a reference speed. Say for example, I am driving in a highway for about 60 km per hour. I will be driving at 60 km per hour. My reference speed is also a 60 km per hour. Then in such cases, if I maintain the speed, it is sufficient. I should not apply any brakes or reduce the speed. Directly what I can do, I can maintain the speed. Suppose if the output speed is 100 km per hour, I have to see the speed through my eyes, through a odometer. After seeing the feedback, then I will come to know that the output is more than the input. The brain will be doing control action. So this is how we will be interpreting a manual speed control system with the closed loop control system. Brain will be calculating my reference speed is 60, I am going at 80. So 80 minus 60 is 20. I have to reduce the speed, apply the brake. You can apply the brake through hands or through legs. After the application of brake, the speed is reduced. Again, I will check whether the speed is reduced or not. If it comes to 60, I will be continuously doing this cycle. So this is how closed loop control system will work. At every stages, you will get a different output, and each output is measured. The system tries to correct itself automatically. And another important thing in closed loop control system is, first what happens, it will measures the output, measures the variable to be controlled, then compares measured value or feedback value with reference value, then generates deviation or error. Then this error is adjusted, and this error we will make zero practically or theoretically. This deviation is reduced to a smaller value, then again the process repeats. This is how a closed loop control system will work. Many of the systems we have a compromise between closed loop control system and open loop control system. Suppose here, if I find out a measuring device for a bread toaster that will determines the degree of toast. If I calculate, if I invent a device which measures the degree of toast, then my bread toaster will not be getting for just 1000 rupees or 2000 rupees. Instead of that, I have to spend 2 lakhs because the cost of feedback element is more. I have to spend more. So wherever there is a accuracy, I have to spend more money. Wherever there is a less accuracy, I have to spend a little money. So there is a compromise between accuracy and cost in case of open loop control system and closed loop control system. If cost is feasible, you can choose closed loop control system. If cost is more, you can choose open loop control system depending upon the application. Here, bread toaster, if I measure the degree of darkness of the toast, then the cost will be more. Even in automatic machines, if I measure degree of cleanliness of cloth, then the device cost will go up, total cost of the equipment will go up. Hence, there is always trade-off between accuracy and cost while selecting the system. Let us see the comparison of open loop control system and closed loop control system. In open loop control system, there is no control action. Output does not influence whatsoever on the input. But in case of closed loop control system, there is a definite control action. This control action is possible by the use of feedback. If you use a feedback, if you measure the output, then directly you can control the system. Output is measured value is compared with reference value, find out the deviation reduced to 0. This is how we will be using in case of closed loop control system. Next, in open loop control system, we are not going to measure any output. There is no output measurement. See here, there is no loop after the output. Whereas in closed loop control system, we will be measuring the output. So that is the second point. No output measurement is there in open loop control system. Output measurement is required in closed loop control system. Then open loop control systems are subjected to sensitive, and they are very sensitive to disturbances. So suppose if you take any electronic device vicinity towards any open loop control system, then that will interfere into the waves and that will give other output. So that's why open loop control system are high sensitive. It can be a temperature or it can be anything. So place a bread toaster with a high temperature environment. Then bread toaster will work indifferently because it is very sensitive. Suppose if you take the same bread toaster to any other hilly regions, it will work differently because it is sensitive to temperatures. And closed loop control system will not so sensitive. Most of the times they are not designed for sensitive because of output correction or error correction. Since you are measuring the output, you are measuring the error is corrected. So since error correction is possible in case of closed loop control system, they are not so sensitive to disturbances. If any sensitivity is there, that will be adjusted in the feedback cycle itself. That is one of the advantage in case of closed loop control system. Then repeatability is high. Repeatability is nothing but ability to reproduce the same result. Whereas in closed loop control system, repeatability is less. Say the same bread toaster, after 2 minutes, you will get the same degree of intensity of toast. Whereas in speed control of automobile, it is reaching, say for example 80, you will try to always bring it towards reference speed. So in each cycle, this cycle output is 80 km per hour, next cycle output can be 70 km per hour, next cycle it can be 72 km per hour. So at each cycles the output is not constant. That means you are not getting any repetitive results. That's why repeatability is less in case of closed loop control system. Also another important thing is the system tries to overcorrect itself. That is one of the drawback here. Whenever if it is giving exactly 60 km per hour as an output, it will tries to maintain 60.0 at each cycle. So accuracy will be executed in each cycle. That is one of the negative thing. Because of this, the system tries to overcorrect itself. There might be increase in power or there might be increase in any other electrical quantities. Because of this, power consumption might be high. That's why the system tries to correct itself. This point is almost reduced. Next, less accurate and irreliable open loop control system. Less accurate means accuracy is less compared to closed loop control system. We are not comparing other thing. Comparison with closed loop control system. Closed loop control system will have more accurate and more reliable than open loop control system. Then open loop control systems are inherently stable. There will be no problem of the bread toaster that is inherently stable. Almost all the open loop control systems are designed for stability concern. There is no problem with stability. But in case of closed loop control systems, there might be stability problems because of this overcorrection. That's why we will see the stability condition while designing closed loop control system. It should be stable. Then it is very simple and cheap, less costly, whereas closed loop control system complicated and more costly. Then bandwidth, that is operating frequency range, is very small in case of open loop control system. Operating frequency range is high in case of closed loop control systems, and open loop control systems will subjected to non-linearity and distortions. Here in closed loop control systems there is no effect of non-linearity and distortion. Sometimes the system behaves non-linearly. Non-linearly in the sense is nothing but if you give a small amount of acceleration, the speed should go up in a small base. So acceleration is proportional to increasing the speed. If you give more acceleration, speed should be more. This is a linear output. If you give a small amount of acceleration, if it increases to 100 km per hour, then the system is behaving like non-linear fashion. So all electrical system must behave like a linear system. That should always be there in all the electrical system design. Electrical systems should listen to you. Listen to you is nothing but it should be a linear. If it is non-linear, it will not listen to you. The output will be varying in each cycles. So this is one of the important thing in case of open loop control system and closed loop control system. Whenever they ask in the examination, first you write the definition, then block diagram and example. If this question is asked for 8 marks, then write everything, definition, block diagram, some 2 to 3 lines explanation, then the differences. This will fetch you complete 8 marks. Welcome back for the session. In this session we will be handling what is robotics and what are the different types of joints and links, and also different types of joints, and along with some industrial application of robots. Let us see what exactly is robot. A robot is programmable multipurpose manipulator capable of moving in several directions, equipped with an end effector or tool, and capable of performing factory work normally done by humans. So basically it is a programmable. It can be programmed or reprogrammed. We can alter the sequence of program like that. Then multipurpose. It cannot be used only for single use, it can be used for multi-use. So that is a multi-purpose. Manipulator. Manipulator, it is just like a part of body. So imagine a human being. So suppose if I cut the leg, this portion is nothing but manipulator. So this is a manipulator. Same thing, robotics will also have the manipulator. Below the manipulator, we have a legs. Instead of legs, we can have even a wheel. So if you have a wheel, it is a wheeled robot. If you have a leg, it is a legged robot. The same functioning like a human beings. And these are the joints and these are the links. Joints and links are nothing but it is also one of the part of the robot. Same thing, manipulator. This is a joint, elbow joint, and this is a link. Similar configuration we will be taking in robotics also. And capable of moving in several directions. You can move robot in any of the fashion. You can have a linear motion. You can have a motion like this. You can have a motion like this and circular motions. So this is nothing but work envelope. How much I will be using? Work volume. So the ability of a robot hand to reach over the space is nothing but work volume or work envelope. So there are different types of work envelopes. It can be a linear, it can be a cylindrical, it can be a polar, spherical, etc., and even an irregular. So those configurations are nothing but several directions. This is also explained in degrees of freedom. It is number of independent coordinates which requires to describe the directions. That is nothing but degrees of freedom. Several directions with an end effector. End effector means this is the end part. We have a fingers. We have a fingers. In the robots, we will call this as end effector. Even that can also have a fingers, that can have a tool, so that can have a gripper. So anything holding device is nothing but a gripper. I need to hold some device. For that I need to establish a grip. So this itself is a grip. So this end effector will be having a gripper or a tool. It can, if you are using a welding, then it is a tool, welding tool. Painting, it is a painting tool. Suppose I want to pick and place something, then I have to use grippers. Then capable of performing factory work, it will performing factory work like a human, normally done by human. Same thing, that is nothing but anthropomorphic data, that is nothing but it is study of humans. The same thing robot will also perform. We can say it is a replacement for human in most of the cases. And let us see what are the different components of robots. Mainly the different components are manipulator, as I already told, it is a body of the robot and which has an arm, and joints and links, that is also one of the part of the robot. Along with a controller should be there. Controller is very important to control the robot, and also a programming display. These are the different components of robots. And let us see what is joints and links. Joints is nothing but, these are the joints, joint 1, joint 2. Similarly, we have an elbow joint which is fixed, which gives connection for multiple links. This joint will give connection for link 1 and link 0. This is a base. Above the base we have a link 0. Then we have a joint, say joint 1, then again link 1, joint 2, link 2. This is similar to a hand. If I draw like this, it is a similar to hand. This is a joint and these are the links. This is also a joint. Here I will be using an end effector, gripper or tool. So this is how joints and links will work. There are different types of joints. Basically, joints are classified into two groups. One is linear joint, another one is rotary joint. So precisely we will tell, one is translation joint which provides linear motion, and another one is revolution joint or rotational joints which provides rotary motion. Basically, the joints which provides linear motion, we will call it as prismatic joint. The joint will provide circular motion or rotational motion, it is nothing but revolute joint. So whenever we say configuration, we will be using the suffix P and R for prismatic and revolute joint. Let us see the different types of joints. Number one, it is a linear joint. The name itself indicates linear. It will give linear motion or translation motion. So this is an input link and this is an output link. Here input link is parallel to output link. The joint provided here is a linear motion or a translation motion. Got it? Then orthogonal joints, the name itself indicates orthogonal, means it is perpendicular to each other. Input link and output link are perpendicular to each other. The joint motion is also perpendicular. Then rotationally joints, before that these two are categorized into linear joint or prismatic joint. These two joints are prismatic joints. So I will call it as P. P is nothing but prismatic joint. Prismatic joint will provide linear motion, and R is revolute joint or rotational joint which provides rotary motion. Simply you can say linear motion and rotary motion. Rotational joints, here rotational joints, input link and output link are there, and the motion what you are getting is a rotary motion which is perpendicular to input and output link. This is perpendicular to input and output link. We will also call it as R joint. Then twisting joint. Twisting is nothing but twisting. It is torque force we are applying. Twisting joint is we are applying parallel to, when we tear the paper, we are applying parallel to paper. So that is the direction of force, how it is going. So the direction of force going parallel to the paper, that's why the name twisting joint. It is parallel. And finally V joint. Here input link is parallel and output link is perpendicular. You are getting the rotary motion parallel to input link and perpendicular to output link. So this is nothing but revolute joint or V joint. So these are the different types of joints we are using in robotics. Number one, linear joint, orthogonal joint. These two are prismatic joint. Then rotational joint, twisting joint, revolute joint. These three are rotary joint. There is another important thing in robotics is the robot configurations. Basically, there are four types of robot configuration. Number one, polar configuration, or it is also called as spherical configuration. Next, second one, cylindrical configuration. Number three, jointed arm or articulated robot configuration. And finally, Cartesian robot configuration. These are the four important robot configuration we'll be using generally. Let us see in detail what exactly is polar configuration. In polar configuration, we have two rotational joints. It can be anything. It can be R joint, it can be T joint, it can be V joint. It can have one R joint, one T joint. It is a permutation and combination of these joints. Even you can have two revolute joints, two V joints, that is also possible. Two or P, two rotational joints, one prismatic joint, that is nothing but polar configuration. The work volume for polar configuration is spherical type. Then cylindrical robot configuration. Cylindrical robot configuration will have, cylinder will have two linear dimension, one rotary dimension. Two linear dimension means two prismatic joints, 2P. It can have L and O, even it can have L and L, it can have O and L, depending upon the type. So two prismatic joint, one rotational joint. That is a configuration for cylindrical type robot configuration, and the work volume for cylindrical robot configuration is generally cylinder. Then articulated robot arm or jointed arm robot configuration, very important. Here we will be having three rotational joints, that is nothing but 3R we can say. It can have three rotational joint, it can have three twisting joint, it can have three V joint or revoluting joint, or it can have one each. It is a combination and permutation of these three joints. So it is having three rotary and no prismatic rotation. So 3R is the total degrees of freedom given for jointed arm or articulated robot configuration. The work volume for articulated robot is irregular. We can use any irregular shape. We can shape it easily using articulated robot configuration. Next, final robot is nothing but Cartesian coordinate or Cartesian robot configuration. It is having three prismatic joint. 3P is nothing but degrees of freedom for Cartesian robot configuration, and the work volume for Cartesian robot configuration is rectangular work coordinates. Rectangular objects we can work easily in Cartesian robot configuration. These are the different configuration of robots based on body and arm. Polar is 2PR, work volume is spherical. Cylindrical, 2 polar, 2RP, work volume is spherical. Cylindrical, work volume is 2PR, it is cylinder. Then jointed arm or articulated robot configuration, 3R, irregular work volume. Then last Cartesian robot configuration, 3P, work volume is generally rectangular in nature. Apart from this, there are some more configuration we can add. One is SCARA is there. SCARA is one of the spherical robot or polar robot configuration, so which is modified. That is also there. That is a special case of robot arm we will be using. And these are nothing but basically robot configuration, body and arm configuration of the robot. Whenever they ask joints, please write this. Whenever they ask body configuration, you write that polar, spherical or cylindrical, jointed arm and Cartesian robot configuration. Some of the important thing in the robot is we have lot application of robotics, even in industrial application, even in medical application, etc. Lot of applications are there in robots. Why the robot is chosen? There are primary advantages of robot. Number one, whenever there is a hazardous situation for humans, robots are replaceable. So I cannot go to space very easily. I can go to underwater and I cannot weld easily. So in such cases, definitely I need a robot. So wherever it is impossible to work for humans, I need to place a robot. Even a painting situation is also somewhat irritating to me. One day, 2 day, okay. Hours together, shift together, how can I handle the paint? So respiratory problems will be arising. That's why robots are suitable. Even I want to go for moon, I want to go for Mars. I cannot go because life question is there. In that cases, robots are very useful. Underwater welding, submarines, I cannot go very easily. In such cases, robots. Wherever hazardous situation for humans, robots are replaceable. Then another thing is repetitive work cycle. This repetition of work cycle will lead to fatigue. Because of this, there might be stress induced in the human brain. In such cases, we will be using robots. Say for example, I want to handle 25 kg rice a day. Say for example, I want to handle hundreds of 25 kg rice in a shift. So second shift, third shift, like that. If I handle more than 100 bags of rice for about 25 kg, then it is a repetitive task. It is very huge and I will break out very easily. So in such cases, robots will be used. Not only in lifting application, it can also be a repetitive. I have to check 100 devices daily, same component, same. It is again repetitive task. So in such cases, robots are replaceable. Then difficult handling for humans. Some of the things, chloroform, it is very difficult to handle. Pharmaceutical industries will be running in continuous production, continuously, day by day. More than 1 lakh components will be produced, tablets. In such cases, I cannot handle chloroforms very easily. It is very difficult. Sanitizers, it is also difficult to handle. Alcohol content will be there. That will get reacted to the body. So that's why, in such cases, robots are must. Then multi-shift operation. I need to continue first shift, I need to continue second shift. Like this, shifting works are there. So for this shifting works, again, it is very difficult for the humans. Robots are suitable for that. Then infrequent changeovers. Infrequent changeovers means I am changing one work to other work. I need to some time. Today I will be there in material handling. Tomorrow I will be there in inspection. How to change it? So I will take some time. Because earlier I was working in material handling. Now I am working in inspection. 1 week, 2 week time, I will learn everything. Then I will start working it. Robot is not like that. Directly it will do. That is one of the flexibility of robots. You can have a robot in anywhere. Even material transfer robot can be shifted to inspection. Inspection robot can be shifted to spray painting. Spray painting robot can be shifted to welding. But it is very impossible for the humans. Suppose if I am doing inspection today, I cannot shift to processing operation very easily. There is a problem on that. Suppose if I am doing spray painting today, I know how to do spray painting and all. Tomorrow if you put the same for material handling, it will be tough for me. Even instead of spray painting, if you use for any other works like welding, it is also difficult for me. I need to learn welding and I need to adjust it. So that's why infrequent changeovers robot will do very easily. Next, finally, part position and orientation. Part position and orientation will be also done by robot very easily. It will be placing exactly without any human errors. So because of this, the robots are very suitable. Let us see the different applications of robots in material handling. So basically material handling will have two types of important applications. One is material transfer and another one is machine loading and unloading. Let us see what is material transfer. In material transfer, the robots are used for various applications like sequence control. I need to place a component sequentially, one after the other. That is nothing but palletization, one above the other. I want to arrange the blocks one above the other. I want to put some storage on the bins. So these things will be done by robotics very easily. This is one of the palleting operations, what we have seen. Palleting operations will be done by robotics. And next, second one is machine loading and unloading. In machine loading and unloading, there are many things. One is we need to load the machine, loading the work part to the machine, then unloading the work part to the machine, then both machine loading and one unloading. So without robot and with robot we can do. Without robot, again, human has to bear that. If it is having more weight, it is very difficult. Robots are suitable for that material handling device. Then industrial robot applications of machine loading and unloading includes die casting. Die casting, the robot unloads parts from the die cast material and it is subjected to cooling. That is also one of the advantage. Plastic molding, we cannot handle sudden high temperature plastic very easily, but robot can handle. So that is one of the advantages of robot. It is also similar. High temperature mold should be handled by the robot. Then metal machining operation. Metal machining operation, chips will be there. It is very difficult to hold the component. There are some burrs. That burrs will cut the fingers and all. So it is very dangerous sometimes. Robot will handle efficiently. Then forging operation. Again, high temperature forge material. It is very dangerous to handle. We need to wait up to cooling temperature. After that we can handle. Then robot can handle those things at high temperature only. Then press working operation, sheet metals operation. Robots are nicely used there because in sheet metals, sharp metals may cut the human material, but robot will handle comfortably. Most of the press working operation will be done by robots nowadays. And heat treatment, very important process. Heat treatment, robotics will be handling efficiently. Then also processing operation is also there. Processing operation is nothing but it is just like arc welding, spray painting, spot welding, these things. Spot welding will require some skill to identify the spots, but robot can automatically identify the spot based on the programming. That is one of the advantage. The same spot welding robot can be replaced with arc welding. It is very difficult for the humans because I need to have a training on spot welding and then I need to have a training on arc welding. I need to take training, then I have to work. So whereas robot, without training it will work. Today it can be used for spot welding. Tomorrow I can replace it for arc welding. Only thing is the programming is changed. That is one of the flexibility of robot. Apart from this is spray coating. That is also one of the important. Spray painting. Whenever we will be doing in the car, there might be problem in thickness, layer thickness. So robot will handle it very easily. Some of the minute things we cannot see through our eyes, but robot will identify the fault and it will do. That is one of the advantage of spray coating and spray painting. Some of the other applications also we can do in the robots like drilling, routing and other machining operation. Drilling can be done very easily, effectively, and even grinding, wire brushing and similar operations that can be done. And even water jet cutting, that is also one of the advantages. The jet we can easily place it at exact location and we can get intensity of water jetting. Even laser cutting, laser surgery is also doing nowadays robotics. That is advancement level. Cataract surgery automatically it will be done by robot. That is how the robot is handling nowadays. Robot technology is highly appreciated. And even laser cutting is also, some of the times we need to give a coordinates exact dimension. Otherwise what happens, there might be improper light resources usage. So that's why proper path should be given for the robotics, and that will be taken care by robot very easily because of programming. That interface is very flexible for us. We can give any irregular shape path, directly the robot will take. Apart from these processing and operations, assembly and inspection is also taken care by robot. Assembly, it can be welding, brazing, soldering, anything. These things can be done using a robot. Even it can be a temporary joint fit like nut and bolt through highest welding. So anything can be done by robot very easily and efficiently. Some of the things we can incorporate like assemblies, sub-assemblies, etc. And even we can get a good tolerance of fit due to robot. it is an exact match. It is very easy because of robots. Then also inspection. In inspection, we can ensure whether the process is completed or not. That is also we can do very easily. And apart from that, we can ensure whether the parts have added in the inspection or not. That is also monitored very easily. And identifying flaws in raw material and finished product, that is very important. Condition monitoring, most of the times condition monitoring robots are used even in all, after each operation, like after some processing operation, we can do inspection there itself. That is nothing but online inspection. Nowadays, coordinate measuring instruments are used. Coordinate measuring instruments, CMMs, they are most popular. They will detect flaws very accurately, and they have a flexible configurations. These are the several advantages of robots. Apart from this, there are many applications. Just we are concentrating only on industrial application. Even you have medical application of robots. Even you have other applications. So these are the several things we'll be using in robots. And robots are very flexible nowadays. But only some of the three important laws you have to know about robots. That robots should not harm any humans. So that is very important. And if that is harm, it is very punishable, and it is we are going away from the law. So robots should listen to the humans. It should not violate the human guidelines. So that is very important. These three laws are very important in the robots. And more so ever, we can extend the technology of robotics. Nowadays, we can fetch artificial intelligence to the robots that will work automatically, that will make decisions, quicker decisions like a humans. Because of that, the process can be made faster. These are the several advantages in robots, and thank you for the session.